Okay, so question number first says a bird moves with velocity 20 meter per second in a direction making an angle of 60° with the eastern line and 60° with vertically upward. We have to write the velocity vector in rectangular form. Okay, so from the direction cosines, first we will make the directions this as east, west, north, and south. As that is it is making an angle of 60° with eastern lines. Alpha we can write is 60°, beta we don't know, and value of gamma we have given 60°. So from the relation of direction cosines, we know that cos square alpha plus cos square beta plus cos square gamma is equals to 1. So cos square 60 plus cos square beta plus cos square 60 is equals to 1. So 1 by 2 square will be 1 by 4 plus cos square beta plus 1 by 4 is equals to 1. Cos square beta will be equals to 1 minus 1 by 2, that is equals to 1 by 2. So from here we can write cos beta as 1 by root 2. So beta we can write is 45°. As now we have to write its vector. So velocity vector will be 20 cos 60 I cap plus 20 cos 45° j cap plus 20 cos 60 k cap. So answer would be tan I cap plus tan into j cap plus tan k cap. So B option would be the correct answer. Now let's come to the second question. We have given a vector A makes an angle 240° with a positive x-axis. So we have to find its components along x and y-axis. So first we will make this x-axis and this y-axis. Now we have to make an vector A as it is making angle 240° with the x-axis. So it comes out in the third quadrant. So that total angle will be 180° on the above and 60° with this. So if we do its component, then that component will be a cos 60 and this component will be a sin 60. So ax, the component in x direction, we will write minus a cos 60 because it is in negative x-axis. So it would be minus a by 2. And we will write component in y-axis, which is minus a sin 60. That would be minus a root 3 minus a root 3 by 2. So C option would be correct answer. Now let's come to the next question, the third question. We have given the potential energy of a particle is given by the expression ux is equals to minus alpha x plus beta sine x upon y. And we have asked the dimensionless combination of the constants alpha, beta, and gamma. Okay, so from the dimensional analysis, we know that any trigonometric term has the angle as dimensionless quantity. So x by y should be dimensionless, right? So dimension of x should be equals to dimension of y. And from here, we can see this alpha x and beta should be of same direction. So alpha x should be of same dimension as that of beta. So in place of x, we can put y. So alpha y should be the same dimension of beta. So alpha y upon beta should be dimensionless, right? So D option should be correct. Now in the fourth question, which is the next question. We have asked which of the following has the highest number of significant figures. In the first one, the A option, it is given, we have given, it is 0.007 meter square. We have given we can clearly see it has one significant figure. In the B option, we have 2.64 into 10 to the power 24. It has three significant figures. In the C option, we have 0.0006032. It has four significant figures. And D option, we have 6.3200. So it has five significant figures. So D option would be correct answer. In the next question, fifth question, we have given its mass as m is equals to 0.3 plus minus 0.003 gram. Its radius we have given 0.5 plus minus 0.005 mm, and its length we have given is 6 plus minus 0.06 centimeter. Now we have to find out the maximum percentage error in the measurement of its density. So density we know is mass by volume. A cylinder's volume we can write is pi r square L. Now from the errors formula, we can write maximum error in the density as delta d by d is equals to delta m upon m plus 2 delta r upon r plus 2 delta L by L. As we have to find it in percentage, so we have to multiply 100 on both sides. So percentage error comes out to be, as we can see, delta m is this 0.003, and m we have 0.3. So 0.003 upon 0.3 plus 2 delta r we have this 0.005. So it would be 2 into 0.005 upon this 0.5 plus delta L we have 0.06 upon 6 into 100. So that would be 0.01 plus 0.02 plus 0.01 into 100. So percentage error would be 4%. The fifth question. So D option would be correct answer. Now let's come to the sixth question. Let's come to the sixth question. We have given in a vernier calipers, one main scale division is x centimeter. One MSD we have given x centimeter. And we have given that n divisions of vernier scale coincides with n minus 1 divisions of the main scale. So we can write n VSD is equals to n minus 1 MSD. So from here, 1 VSD, we can write n minus 1 upon n MSD. Now we have to find out least count. So we have this formula of least count as none MSD minus 1 VSD. So it would be 1 MSD. In place of VSD, we will put n minus 1 on n MSD. So if we take MSD common, 1 minus n minus 1 upon n. So n minus n plus 1 upon n into 1 MSD. In place of 1 MSD, we can put x centimeter. So least count would be x by n centimeter. So C option would be correct answer. Now let's come to another question. The seventh question. In seventh question, we have given the velocity time graph of body is shown in the figure. The slope of the line is small m, and we have to find the distance traveled by the body in time t. Okay, so this VT curve we have given. This is given as t. So we have given its slope as m. We know that the velocity time curves slope is acceleration. M will be equals to acceleration. So from here, slope we can write v by t. And as we can see, its acceleration is constant. So we can use this equation, second equation of motion, as is equals to ut plus half at square. As we can see from the graph, initial velocity of it is zero. This would be zero. In place of acceleration, we can put this v by t into t square. Now from here, in place of t, we can put this v by m. So v by 2 into v by m. So displacement comes out to be v square by 2m. So D option would be correct answer, right? Now let's come to the next question, the eighth question. We have given a particle moves along a straight line y at a time t. The distance x in meters of the particle from O is given by x is equals to 50 plus 12t minus t cube. And we have asked how long the particle travels before coming to rest. So it comes to rest, so its velocity becomes zero. Now velocity we can write dx by dt, so it should be 12 minus 3t square. It should be zero. So 12 should be equals to 3t square. So t square should be equals to 4. So t should be equals to plus minus 2. As time can't be negative, so t comes out to be equals to 2 seconds. Now we have to find distance traveled by it. So first we will find its position at t is equals to 0. So if you put t is equals to 0 in the given equation, this equation, it would be 50 plus 0 minus 0. So it would be 50 meter. Now we will find out its final position, which is at t is equals to 2 seconds. So this comes out to be 50 plus 12 into 2 minus 2 cube. So this would be 50 plus 24 minus 8. That would be 66 meter. This is the position of it at t is equal to 2 seconds. So distance traveled by it, distance would be 66 minus 50, which is 16 meter here. So D option would be correct answer. D option would be correct answer, 16 meter. Now let's come to the next question, which is ninth. In the ninth question, we have given a body starts from rest from the origin with an acceleration of 6 meters per second square along the x-axis. So Ax would be 6 meter per second and Ay we have given 8 meter per second square. We have to find out its distance from the origin after 4 seconds. So first we will find net acceleration. So A net can be written as under root Ax square plus Ay square, which is under root 6 square plus 8 square. That would be 36 plus 64, which comes out to be 10 meter per second square. And net comes out to be 10 meter per second square. As it is a constant value, we can use as equals to ut plus half it square, as we have given in the question. Particle starts from rest, so u will be 0. So as comes out to be half into 10 into 4 square. So that comes out to be 80 meters. So C option would be correct answer. Now let's come to the next question, which is 10th. 10th, in the 10th question, we have given a particle is projected with velocity v so that its range on a horizontal plane is twice the greatest height attained. So range would be equals to 2h. And if g is the acceleration due to gravity, then we have asked its range. Okay. We have given its range on a horizontal plane is twice the greatest height attains. Okay, so we can write u square sine 2 theta upon g is equals to u square sin square theta upon 2g, right? This we have given. U square got cancelled out, g got cancelled out. In place of sine 2 theta, we can use 2 sine theta cos theta is equals to sine square theta divided by 2. From here, this got cancelled out. So we can see uh, here the 2 was also there. So 2 got cancelled out. This got cancelled out. So we can see tan theta would be equals to 2. And we can also write it as 2 by 1. So from the right angle triangle, we can write it as perpendicular upon base. So if we make this right angle triangle, then if this would be 2, this would be 1, then this would be under root 5. So if this is theta, then sin theta will be 2 by under root 5, and cos theta would be 1 by under root 5. So range we have to write down. So range formula we know is u square into sin 2 theta, which we can also write to sin theta cos theta because we have values of different sin theta cos theta. So in place of u, we will put v. So this will be v square into 2 into 2 by under root 5 into 1 by under root 5 upon g. So that comes out to be 4v square by 5g. Okay. So A option would be correct answer. Okay. Now let's come to the next question. The 11th question. We have given a projectile is thrown with an initial velocity of v is equals to ai cap plus bj cap. We have given if range of the projectile is double the maximum height attained by it, then. Okay, so from this we can write ux, which is the initial velocities component in x direction, which is a here, and uy will be b here. So range of the projectile is double the maximum height. So range we know we can write 2ux uy by g. H will be uy square by 2g. So this g got cancelled out. This 2 got cancelled out. This got cancelled out. Now in place of ux we can put a. So 2a comes out to be equals to b. So C option in this case would be correct answer. Now let's come to the next question, the 12th question. We have given a projectile is thrown with an initial velocity. The 12th question, we have given a boy throws a ball with a velocity u at an angle theta with the horizontal. At the same instant, it starts running with a uniform velocity to catch the ball before it hits the ground. To achieve this, he should run with a velocity of. Okay, so first we will make this situation. So this situation will look this, like this. And the person starts running with some velocity, let's say v. So to catch the ball, the horizontal component of velocity of ball and the person should be same. So v should be equals to g cos theta. So A option should be correct answer. Now let's go for the next question, which is 13. So in the 13th question, we have given a stone projected with a velocity u at an angle theta with the horizontal reaches maximum height h1. When it is projected with velocity u at an angle pi by 2 minus theta with the horizontal, it reaches maximum height h2. The relation between the horizontal range r of the projectile h1 and h2. We know that when the particle is thrown with two angles like theta and pi by 2 minus theta, its range would be the same, which is u square sine 2 theta per g. Its maximum height h1 we can write u square sine square theta by 2g. Now in place of theta, if we put pi by 2 minus theta, then we know sine 90 minus theta is cos theta. So we can directly write this u square cos square theta by 2g. Now if we put all the relations, all the values, this in the first option which we have given, R is equals to 4 under root H1 H2, then it will satisfy this relation. It will satisfy this relation. So A option would be correct in this case, right? Now let's go for the next question, 14. In the 14th question, we have given a board which has a speed of 5 km per hour. So VB would be 5 km per hour. In still water, crosses a river of width W, which is 1 kilometer along the shortest possible path in 15 minutes. For T, we have 15 minutes, which we can also write it as 1 by 4 hours. Okay. Now we have to find velocity of river or velocity of water. So VW we have to find out. Now we have direct formula for this. We have direct formula for times, which we have T is equal to W upon under root VB square minus VW square. Now W we have 1. VB we have 5. VW we have to find out. And time we have 1 by 4 hour is equals to 1 upon under root 25 minus VW square. If we square on both sides, then 16 comes out to be equals to 25 minus VW square. So from here, VW square comes out to be 25 minus 16, which is 9. So VW will be 3 km per hour, right? So B option would be correct. Let's go for the next question. We have given man is running uphill with a velocity of 2i cap plus 3j cap meter per second with respect to ground. So velocity of man, we have this 2i cap plus 3j cap meter per second with respect to ground. He feels that the raindrops are falling vertically with velocity 4 meter per second. So he feels that it means that velocity of rain which we have given is with respect to man of t. So that will be minus 4 j cap meter per second because it is falling vertically downwards. So from here we can write it as VR minus VM is equals to minus 4 j cap. So VR we have equals to minus 4 j cap plus VM. This will be minus 4 j cap plus 2i cap plus 3 j cap. From here, VR comes out to be 2i cap minus j cap meter per second. Now, in the second scenario, the person runs down with the same speed. So, as a person runs down, so velocity of main will be in just opposite direction. As a finisher, it will be minus 2i cap minus 3j cap meter per second. Now, in this case, we have to find VRM. So, VRM in this case would be VR minus VM. So VR we have 2i cap minus j cap minus VM minus 2i cap minus 3j cap. So this comes out to be 4i cap plus 2j cap meter per second, as we have to find its magnitude only. So we will find out its magnitude. So that comes out to be under root 4 square plus 2 square. This will be under root 16 plus 4. So VRM would be 2 under root 5 meter per second, right? So C option would be correct. C option would be correct. Let's come to the next question, which is 16. So in the 16th question, a man is going east in a car with a velocity 20 km per hour. So velocity of man, we can write 20 I cap kilometer per hour because it is going in the east direction. The train appears to move towards north to end. So velocity of train with respect to man would be 20 root 3 j cap because it is appearing north to 20 root 3 j cap kilometer per hour. Now we have to find the actual velocity and direction of motion of the train. So VTM we can write VT minus VM, which we have given 20 root 3 j cap. So actual velocity train would be VT is equals to 20 root 3 j cap plus PM. So in place of PM we can put 20 I cap. Now we have to find its magnitude. So its magnitude would be under root 1200 plus 400. So VT comes out to be 40 meter per second. 40 sorry, it was kilometer per hour because all the values are given in kilometer per hour. And the direction for finding out the direction of motion of the train, we have components east, west, north, south. We have components of it as 20 I cap plus 20 root 3 j cap. So in east direction it is 20. In north direction it is 20 root 3. So this angle comes out to be 60 degree if we do find out. So it is north of east. So its direction would be 60 degree north of east. Okay. Now let's go for the next question, which is 17th. In the 17th question, we have given for an object thrown at 45 degree to the horizontal, the maximum height and horizontal range are related as. Okay, so theta we have given 45 degree, right? So range we will write u square sine 2 theta. So in place of theta we will put 45 degree square sine 2 theta by g. So it will be u square by g. Now maximum height we will write. So maximum height's formula we know is u square sine square theta. So in place of theta we will put 45 degree upon g. So we know that sine 45 degree is 1 by root 2. So square, its square would be 1 by 2. So it comes out to be u square by 2g. Now if we divide them, then r by h and r by h comes out to be sorry, maximum heights formula would be u square sine square theta by 2g, no? So that would be 2 into 2. So that would be u square by 4g. So r by h comes out to be 4. So r comes out to be equals to 4h. R comes out to be equals to 4h. So C option would be correct answer, right? Now let's go for the next question. The 18th question. We have given acceleration time graph of a body is shown. We have to find the correct velocity time graph. So AT graph we have given is this. AT graph we have given is this we have given. Now we know that velocity time graph slope gives us the acceleration. So as we can see in the AT graph, the first slope is positive and constant, then it is 0, then again it is positive and constant. So VT graph would be like this. First slope is constant and positive, so slope should be constant and positive. Then slope is 0, then again it is positive and constant. So graph will look like this. So C option would be correct answer, right? Now let's go for the next question. 19th question. In the 19th question, we have given the velocity versus time curve of a moving point is as given below. We have to find its maximum acceleration. As in the question, we can see the velocity time graph is given. Now we know that acceleration is the VT curves slope, right? VT curves slope. So basically, we have to find out the maximum slope in this question. We can see in the whole graph, the maximum slope lies between the time 30 seconds to 40 seconds. So maximum slope we will find out. So in this case, maximum slope will be 60 minus 20 upon 40 minus 30. So it would be 40 upon 10. So mx comes out to be 4 meter per second square. Sorry, it was velocity was given in centimeters. So mx would be 4 centimeter per second square. Right? Now let's go for the next question, the 20th question. The 20th question, we have given a particle moves along a circle of radius r with constant angular velocity omega. We have asked its displacement magnitude in time t. Okay, so the particle was moving in this circle, right? So let's suppose in this time t it travels some angle theta, which we can write omega t, and we have to find this uh, displacement, right? So its displacement, this displacement we have to find out. So it is just the subtraction of these two vectors, this vector and this vector, and these vectors are of equal magnitude. We know that the subtraction of two vectors magnitude when they are of equal magnitude would be given by 2r sine theta by 2. So that would be our displacement. So in place of theta, we can put omega t. So it would be 2r sine omega t by 2. 2r sine omega t by 2. So D option would be correct, right? D option would be correct. Now let's go for the next question, which is 21st. So 21st question says that a car moves on a straight track from station A to the station B with an acceleration A is equals to B minus Cx, where B and C are constant and x is the distance from station A. We have to find the maximum velocity between the two stations. So we know that velocity is maximum when acceleration is 0. So acceleration B minus Cx, it should be 0 for the velocity to be maximum. So x comes out to be equals to d by c. Now, acceleration we know is v d by d. So from here, we can find the relation of v, then we can put instead of x, we can put v by c. So a we have v minus cx. So v dv, we can write v minus cx dx. Now, if we integrate on both sides, then v square by 2 comes out to be bx minus cx square by 2. So for finding out the v to be maximum, so v maximum square by 2 would be instead of x, we will put this b by c. So that would be b to b by c minus c by 2 into b square by c square. So c, this c got cancelled out. V max square by 2 comes out to be b square by 2c. So 2 got cancelled out. V max comes out to be equals to b by under root c. So A option would be correct, right? Now let's go for the next question. 820. Second question. In the 22nd question, we have given the position of a particle moving along x-axis is given by x is equals to 2 plus 8t minus 4t square. We have to find the distance traveled by the particle from t is equals to 0 to t is equals to 2. Okay, so first we will check if the particle is turning before moving or not. So we first we will find velocity, which we have v is equals to dx by dt. That would be 8 minus 8t. It should be equals to 0. So t would be equals to. So at t is equals to 1, it will make a turn. That means the particle is moving like this. Like this, it is moving. So first we will find out its position at t is equals to 0. So x at t is equals to 0 would be 2 plus 0 minus 0. It means it is 2 meter. So at t is equals to 0, it is at x is equals to 2 meter. Now we will find its position at t is equals to 1. So x at t is equals to 1 would be 2 plus 8 minus 4, means it is 6 meter. Now we will find out its position at t is equals to 2. X at t is equals to would be 2 plus 8 into 2 minus 4 into 2 square. That would be 18 minus 16, which is 2 meter again. So at t is equal to 2, it is at 2 meter again. So between 6 meter to 2 meter, it travels 4 meter. And between 6 meter to 2 meter again, it will travel 4 meter. So total distance would be 4 plus 4, which is 8 meter. Total distance would be 8 meter. So B option would be correct answer. Right? B option would be correct. Now let's go for the next question, 23rd question. We have given a bus appears to go with a speed of 25 km per hour to a car drive. Means velocity of bus with respect to car we have given 25 km per hour. Driving at a rate of 7 km per hour northwards, means velocity of car we have given 7 j cap kilometer per hour, because it is moving in north direction. If the bus actually travels in east direction, its speed would be okay. So VBC, we can write VB minus VC. Now we have given bus actually travels in the east direction. So let's suppose it is VI cap minus 7 J cap, it is VBC. So we have only given its magnitude. So if we find out its magnitude, then VBC, which is 25 we have given, it is under root V square plus minus 7's whole square, right? So that would be 625 is equals to V square plus 49. So V square comes out to be equals to 576 and V comes out to be equals to 24 kilometer per hour, right? So A option would be correct answer. A option would be correct answer. Now let's go for the next question, the 24th question. So in the 24th question, we have given that a displacement vector of magnitude 4 makes an angle 30° with x-axis. So we have to write its rectangular components in the xy plane. Okay, so first we will make this. This is the x-axis, this is y-axis. This would be 4. This would be 30°. So this would be 4 cos 30. This would be 4 sine 30. So x component would be 4 cos 30. It is 4 into root 3 by 2. So that would be 2 root 3. The y component would be 4 sine 30. So it would be 4 into 1 by 2, which is 2 here. So A option would be correct. Now let's go for the 25th question. Next question. So in the 25th question, We have given a shell is fired vertically upwards with the velocity given from a trolley moving horizontally with velocity v2. A person on the ground observes the motion of the shell as a parabola whose horizontal range is. Okay, so the horizontal component of velocity we can write ux is equals to v2. The vertical component we can write uy is equals to v1. Now range we know is 2ux uy by g. So range comes out to be 2 v2 v1 by g. That would be range. So D option would be correct answer in this case. Okay, so let's go for the next question, 26th question. The 26th question we have given that if the time of flight of a bullet over a horizontal range r is t, then the angle of projection with the horizontal edge t. Okay, so time of flight we can write 2u sin theta by g. So from here u we can write gt upon 2 sin theta, that we can write. Now range we know is u square into sine 2 theta by g. So if we put the value of u from here, then this would be g square t square upon 4 sine square theta into, in place of sine 2 theta we can put 2 sine theta cos theta upon g. So this got cancelled out. This will get cancelled out. This g got cancelled out. So range would be gt square upon 2 tan theta. So from here, theta, we can write tan inverse gt square upon 2r, right? This we can write. It is square upon 2r. So A option would be correct in this case, right? Now let's go for the 27th question. The 27th question we have given in the graph shown in the figure, which quantity associated with projectile motion is plotted along y-axis. So if we draw this graph, this is given as time axis, this is y-axis, this graph is given as constant. So in the projectile motion, we know that the horizontal component of the velocity always remains same with time. So C option which says horizontal velocity, C option which says horizontal velocity would be correct in this case, right? Let's go for the next question. The 20th question, we have given the equation of projectile is y is equals to ax minus bx square, and we have asked its horizontal range. So we know that the equation of trajectory would be given by y is equals to x tan theta 1 minus x pi r. So we will write our equation in terms of this only. So that would be y is equals to ax 1 minus bx square upon a x. So this x got cancelled out. That comes out to be ax 1 minus x upon a by b. So we can clearly see in place of horizontal range, we have this a by b. So A option which says a by b would be correct, right? Now let's go for the next question, which is 29th. In the 29th question, we have given a particle is moving in a circle of radius r, having center at O with a constant speed v. We have to find the magnitude of change in velocity in moving from A to B. So situation is something like this. This is velocity v at this point, and at this point it is v, right? We know that when two vectors are of same magnitude, then their subtraction would be given as 2a sine theta by. So in this case, the magnitude of the vector is v, and angle we have given 60. Now sine 60 divided by 2 is sine 30. So that would be 2v sine 30. Now we know that sine 30 is 1 by 2. So delta v comes out to be equals to v. So D option would be correct in this case, right? Let's go for the next question, the 30th question. In the 30th question, we have given a car is going around a circle of radius r1 with constant speed. Another car is going around a circle of radius r2 with constant speed. If both of them takes same time to complete the circle, the ratio of their angular speeds and linear speed. We have given they take the same time, complete the circle means T1 by T2. T1 should be equal to T2. So 2 pi by omega 1 should be equal to 2 pi by omega 2. So we can see angular speed of both of them would be same. Means omega 1 by omega 2 we can write 1. Now in place of omega we can put V by R. In place of omega 1 we can put V1 by R1. In place of omega 2 we can put V2 by R2. So from here V1 by V2 we can write R1 by R2. This we can write. So ratio of angular speed would be 1 and ratio of linear speed would be R1 by R2, right? So C option would be correct in this case, right? Let's go for the next question, which is 31st. In the 31st question, we have given equation of motion of projectile in the xy plane is y is equal to x minus bx square, and we have to find angle of projection. So again, we will write the equation of trajectory as x tan theta 1 minus x pi r. So again, we will rearrange this equation. We will take ax common, and it will be 1 minus bx square upon ax. So as we can see, in place of tan theta, we have this a thing, but tan theta we will write it is a. So theta in this case would be tan inverse a. So B option would be correct in this case, right? Now let's go for the next question. 32nd question. We have given a man is running with velocity 5 km per hour towards east. So we can write velocity of man as 5 I cap kilometer per hour, and rain is falling vertically downwards with speed 5 km per hour. Velocity of rain would be 5 k cap kilometer per hour, right? Now we have to write direction of rain with respect to main. So velocity of rain with respect to main would be VR. Sorry, it would be minus 5 kk because it is falling vertically downwards. VR minus VM. So VR would be minus 5 kk minus 5 I cap. So if we find out the angle, then tan theta would be minus 5 divided by minus 5. So it would be 1. So theta would be 45 degree with vertical. 45 degree with vertical. So C option would be correct in this case, right? Now let's go for the next question. We have given displacement R of a particle in xy plane varies with time t is given by R is equals to t square I cap plus 2 j cap meter. We have to find velocity of particle at t is equals to 1 second. So velocity we know is v is equals to dr by dt. So if we differentiate the above equation, then it would be 2t I cap plus 0 because 2 j cap is constant. So its differentiation would be 0. So velocity at t is equals to 1 would be 2 I cap. Would be 2 I cap meter per second. So B option would be correct in this case, right? Now let's go for the next question, the 34th question. We have given two particles A and B starts moving with velocity 20 meter per second and 30 to 2 meter per second along x-axis and at an angle 45 degree with x-axis. So first we will draw this x and this y-axis. Okay, so first one was moving in the x-axis. It is 20. It is 30 root 2. 45 degree. If we do its component, then x component would be 30 root 2 cos 45. We know that cos 45 is 1 by root 2. So that would be 30. And that would be 30 also because sine 45 and cos 45's value is same, which is equals to 1 by root 2. So velocity of A, we will write it as 20 I cap. Velocity of B would be 30 I cap plus 30 j cap. So now we have to find relative velocity of B with respect to A. So VB, A would be VB minus VA. That would be 30 I cap plus 30 j cap minus 20 I cap. So VBA comes out to be 10 I cap plus 30 j cap meter per second. So A option would be correct. Now let's go for the next question, 35th question. The 35th question, we have given a particle is moving in the xy plane in a circular path with center at origin. If at an instant the position of the particle is given by 1 by root 2 I cap plus j cap, then position, let's say it is r vector, is 1 by root 2 I cap plus j cap, then velocity of the particle is alpha. Okay. So this situation is something like this. The particle is at something at this position. This angle is 45 degree and this coordinate would be 1, comma 1, right? Now the particle is either going in the clockwise direction or it is going in the anti-clockwise direction. So depending on that, either its velocity is component in x, x and negative y direction, or it is in negative x or y direction. So both options A and B are correct because it depends on whether it is going in clockwise or it is in anti-clockwise direction. So D option, which says either A or B, is absolutely correct. Now let's go for the next question, which is 36th. In the 36th question, we have given, consider the two statements related to the circular motion in usual notations. So statement A is saying that in uniform circular motion, omega vector, v vector, and a vector are always mutually perpendicular. Okay, let's see that. So in case of uniform circular motion, the speed is constant. So v is always in tangential direction, acceleration is always towards the center, omega's direction will be given by right hand thumb. So it will be vertically upwards or vertically downward direction. So as we can see, these are mutually perpendicular to each other, right? So A statement is absolutely correct. Now let's go for the statement B. In statement B, we have given in non-uniform circular motion, omega vector, v vector, and a vector are always mutually perpendicular. It is not the same case in non-uniform motion, non-uniform circular motion, sorry, because velocity is in tangential direction, but acceleration is the resultant of tangential acceleration and centripetal acceleration. So either it would be in this direction or in this direction, depending on the direction of tangential acceleration. So this will not be mutually perpendicular. So B statement is wrong. So C option which says A is true but B is false would be correct, right? Now let's go for the next question, which is the 37th. So in the 37th question, we have asked which of the following quantities remains constant during uniform circular motion. So uniform circular motion speed would be constant. All the quantities except this speed are variable because the centripetal acceleration, velocity, and momentum are vector quantities and the direction of them are continuously changing. Only thing that is constant would be the option which says speed remains constant. Yes. Let's go for the next question, the 38th. In the 30th, also it is a theoretical question. We have asked the unit of magnetizing field intensity. It is ampere per meter only. It is a theoretical question. Okay. Let's go for the next one, the 39th one. In the 39th question, we have given a car travels first 1/3 of the distance AB at 30 km per hour, next one third of the distance at 40 km per hour, last one third of the distance at 24 km per hour. Its average speed in kilometer per hour for the whole journey is okay. So this is AB. Let's say this is C, this is D, and all the parts are equal to each other. So let's say this is X, X, and X. So it is traveling with 30 km per hour in the first part, 40 km per hour in the second part, and 24 km per hour in the last part. We have to find its average speed. Average speed we know is total distance upon the total time, right? So total distance we can clearly see it is x plus x plus x. Time t1 we can write the distance upon speed which is x by 30 plus x by 40 plus x by 24. So that comes out to be 3x upon LCM of 30, 40 and 24 would be 120. So that would be 4 plus 3 plus 5 x. So x got cancelled it out. It would be 3 into 120 upon 12. So average speed comes out to be 30 kilometer per hour, right? So C option would be correct in this case. So let's go for the 40th question. The 40th question says the vector sum of two forces perpendicular to their vector difference. So it means in that case the forces are okay. So A plus B is perpendicular to A minus B. So dot product of them should be 0, right? So A dot A minus A dot B plus B dot A minus B dot B, it should be 0, right? So this got cancelled it out. A dot A will be A square minus B square is equals to 0. So A square should be equals to B square. So A comes out to be equals to B. Means we can say the forces are equal to each other in magnitude. So B option would be absolutely correct, right? Let's go for the 41st question. 41st question is of type assertion and reason. So in the assertion, we have given that a vector can have 0 magnitude if one of the rectangular component is not 0. It is not possible. It is a theoretical question. A vector has three rectangular components mainly. If any one of them is 0, we still have the two rectangular components remaining. So assertion in this case would be wrong. Reason says that the scalar product of two vectors cannot be a negative quantity. See, A dot B, which is a scalar product, is AB cos theta. Now cos theta can be 0, positive or negative, depending on the value of theta. So it is also can be a negative quantity. So we can say reason is also false. So D option which says if both assertion and reason are false would absolutely be correct answer, right? Now let's go for the 42nd question. 42nd question, in the assertion we have given the angle between the two vectors I cap plus j cap and j cap plus k cap is pi by 3 radian. And in the reason we have given angle between two vectors A and B is given by theta is equals to cos inverse A dot B is equals to AB, right? Which is absolutely correct. So by that formula only we can find out the value of theta. So it would be I cap plus j cap dot j cap plus k cap. Magnitude of A would be under root 1 plus 1. Magnitude of B would be under root 1 plus 1. So it would be cos inverse. I cap dot j cap would be 0. I cap dot k cap would be 0. J cap dot j cap would be equals to 1. So 1 upon root 2 into root 2. So theta would be cos inverse 1 by 2. Cos inverse 1 by 2 would be 60 degree or pi by 3 radian, which is absolutely true. So assertion and reason both are true and reason is the correct explanation. So A option would be correct. Now let's go for the next question, which is 43rd. So in 43rd is a theoretical question which says, assertion says, if the initial and final position coincide, the displacement is a null vector. So this would go like this. The initial and final position are nullified. So in this case, displacement is 0 and the 0 vector is called null vector. It is by definition only. So assertion is correct in this case. And we have given in the reason we have given a physical quantity cannot be called a vector. Magnitude is 0. Reason is absolutely wrong because by definition we can say when the magnitude of a vector is 0, then the vector is called a null vector. So in the 43rd question, the C option would be correct. C option would be correct. Now let's go for the next question. It is by definition it is theoretical question 44th question. The assertion says light year and year both measures in time. So it is completely wrong. Assertion is completely wrong. And the reason says that it is the time taken by the light to reach the earth from the sun, which is also wrong. So D option would be correct in this case. Let's go for the last question, which is 45th. So 45th question says, in the assertion says, if the two particles moving with constant velocities are to meet, the relative velocity must be along the line joining the two particles. So this is a theoretical question. So by theory, it is absolutely correct. And the reason says the relative velocity means motion of the one particle as viewed by the other. So it is also by definition of the relative motion. So A option is absolutely correct in the 45th question. Okay, thank you.